Uh, the question, I'll just show you actually the quick way of doing this, all right? Any question you get where there's one vehicle and it has two to three different sections of its journey should be done using a distance time graph. Okay, does this question qualify? Let's read. It starts from rests with a uniform acceleration and it reaches velocity of 27 meters in 9 seconds. The brakes are then applied and it comes to rest with uniform deceleration after traveling a further 54 meters. Calculate the uniform acceleration, the uniform deceleration, the average speed of the car for the journey, and the times with the velocity of the car will be 15 meters per second. Okay, let's do it. Go on, we'll do it the current way we think about doing it. Here's the current way you guys are thinking about doing it. UVAST, yeah? What's my U value at the beginning? My V? My A? We don't know. My S? We don't know. My T? 9. V equals U plus AT. 27 equals 9A. A equals 3 ms2. Next thing, the uniform deceleration. What do we think there? The brakes are then applied. So what's my initial speed? 27. Okay. 27. What's my V value? 0. What's my A value? Okay. What's my S value? Okay. What's my T value? What formula? U squared plus 2AS? That'd be okay with you guys? Okay. So what we're going to do is 0 squared equals 27 squared plus 2AS, which is 108. Sorry, 108A. So what's 27 squared divided by minus 27 squared divided by 108 to get the A value? Is it? 108. Yeah, minus 27 over 4 or minus 6.75. Now, grand. All right. Okay with that? Now, what's the average speed of the car for the journey? To do that, I'll need to get total distance over total time. So, in the red data, what should I need to do using the red data? I probably need to do S equals UT plus a half AT squared, okay? So what I'm going to do here, okay. Sorry, just a bit of organizational work. Okay, I'm going to use S equals UT plus a half AT squared. Now, what's the U value? 0. So just a half AT squared. Did we find out what A was earlier? What did we find out it was? 3. So a half 3 times 9 squared. So what's a half 3 times 9 squared? And we get 81. Is that 81? That's not 81. 121.5, thank you. Yeah. Now, we did 121.5 in the first part. Yeah. Now, The second part, guys. Okay. We know the distance, but we don't know the time. So what can I say there? Could I use V equals U plus AT and find out the time that way? Your final velocity is 0. Your initial velocity is 27, and your acceleration is minus 6.75 t. 6.75 t equals 27. T equals what then? 27 divided by 6.75. T value of 4. Now, to get the average speed of the car journey, this takes you back to junior cert. Do you remember your DST formula? We're going to do distance divided by time. What's the total distance? 54 plus 121.5. What you get? Yeah, 175.5. How long did it take me to do that? 9 plus 4? 13. 175 over 13? What? Okay, 13.5 kilometers, meters per second. You cool with that? Okay. The 2 times the car will be the velocity of 15. Okay? Ready for this? The 2 times the car will have a velocity of 15. No hassle. I'll go to the red zone. Everybody see the red zone? And here's what I'm thinking. I'll go to the red zone, which is the acceleration zone. And what I'll do is I'll put in 15 here. And we're after the t value, aren't we? And what can I say we're doing? We're using v equals u plus at. Because you accelerate up to 27, which means you obviously have to go through 15 to get there. So here's the first time. Just before I erase that, what was the time a minute ago for the red zone? 9. We'll need that later. That takes 9 seconds to go through the full thing. Okay, so what we're going to say here, V is 15 equals AT equals 3t. Therefore, your t value is 5 seconds. Now, in the blue zone, what we're going to do is we're going to start at 27, but where are we going to finish? 15. Okay. We're going to finish at 15, is it? 27 take 15? Oh, sorry. Messed that up there. 15. Okay. We're going to use V equals U plus AT again. So what do I write down this time? 15 equals 27 minus 6.75 t. 6.75 t equals 12. 12 divided by 6.75. 16 over 9 or 1.78. Okay. Is 1.78 the correct answer? No, because you're already 9 seconds in before the deceleration phase happens. So the answer is 9 plus 1.78, which gets me 10.78. You cool with that? Now, I'm going to show you this full question again, done in a completely different way. Okay? The new way is going to be faster than the old way. You got it? Here we go. Okay? It's very easy. Here's all you need to do. Okay, so I'm rewinding everything. I'm getting rid of the UVasts and I'm going right back to the start, okay? And here's what the method we're looking for. Now, so the method we're looking for is the following. Finally done. Okay. I'm going to draw a diagram called a speed distance diagram. Okay. So distance time, Oh, sorry, not distance time, speed time, velocity time diagram. Okay. What's the first point on my graph? Y. T0, speed 0. What happens? We accelerate. So what way should I point my graph? Upwards. It reaches a peak of what? 27. So the peak is 27. Is that okay? Okay, excellent. Now, next thing, we immediately decelerate. We don't stay at that speed. We immediately decelerate. Now, I don't know how aggressive to make the deceleration. Actually, I do remember. It was more aggressive. The deceleration was more aggressive, wasn't it? It was 6.75. Now, you wouldn't know that right now. So you wouldn't know how steep to make the triangle. But because we have a bit of prior knowledge, we know that the deceleration is steeper than the acceleration. Is that okay? Now, there's a trick that you need to know. See the deceleration phase in blue. The area of the triangle is what? 54. Because the area under the graph is actually the distance traveled. Is that okay? So there's a little kink in the rule there. All right? So that's 50. So that's 54, is it? Okay. Yes. At the point where it changes it to a new speed or decelerating. I haven't done it yet. Okay. Now, guys. Now look at the second triangle. We'll start with the second triangle. Okay. You looking? 54. Now we know that the height of the triangle is 27. And you see this x value here, which is time. Yeah? A half 27 multiplied by x, that's half base times height, isn't it? Is 54. Therefore, x must be, anybody? 54 divided by 27? 2. 2 multiplied by 2? 4. Your time's 4 seconds. Okay? You know that's 4 seconds straight away. Okay? Now, believe it or not, your deceleration, yeah? Your deceleration can be obtained using the slope of the line or the tan of the line. Does anybody remember what tan is again? Opposite divided by? What's 27 divided by 4? I'll save it about 6.75. And it's minus because it's a negative. It's a negative slope, isn't it? So the deceleration is 6.75 ms2. Okay. Now, there's far less writing in this. Okay. Now, next thing I'm going to attack is the acceleration. It says acceleration was 27 meters in how much seconds? 27 in 3 seconds, wasn't it? 27, oh sorry, in 9, I thought, 9. Now, what's the tan of that angle? Angle y, what's the tan of angle y? Opposite divided by adjacent? Yeah, acceleration's 3. It's faster, isn't it? 27 divided by 9, 3. No hassle. Okay. Now, the next thing, and it's a very beautiful thing, this, all right? So let me show you the trick here. We all agree that the second triangle was how big? How much area? 54. Okay, do me a favor. Get the area of the blue triangle. A half base times height. A half 9 times 27. What you get? Is it 111.5? 121.5, my fault. Now, okay, what's the total distance then? Add them together. 165.5, agreed. What's the total? Oh, sorry, 175.5, excuse me. Okay, what is the total time? 9 plus 4? 13. So what you get then? Huh? 13.5. So does everybody see the benefit of this system? That you can do the calculation